So this is the next stage of the tectonics. This is magma plumes and their relationship to plate movement. Now that heading is really important because that's what AQA could ask you about. So what is a magma plume? A magma plume is an exceptionally strong convection current. And where this happens in the world is Hawaii. So I'll just show you this briefly. You've got the Hawaii Islands up here with the Pacific Ocean. So back to here, radioactive decay, just like we've had before, but it's overactive, which actually makes, yes, it makes a convection current, but an exceptionally strong convection current. It's called a magma plume because it is, there's lots of heat there basically. So magma plume, here it is. It's stationary. It's big, it's large, it's not like just the heat rising at the constructive plate boundary in the Atlantic Ocean. It's very strong and it creates this strong convection current. So what does it do? The magma that is created from all of that melting, so from the outer core, from the mantle, collects underneath the oceanic crust. So you've got one single piece of oceanic crust, which is part of the Pacific plate. Because if you know anything about Hawaii, Hawaii is literally islands in the middle of the Pacific Ocean. And there's not a lot else around there. They're really, really isolated. So what happens is that this magma is below the oceanic crust. Let me just slide this one in. And there it is. And it melts that crust above it. So that is similar to the constructive plate boundary. Then what happens is at the bottom of the ocean, the magma gets through and you get small lava flows on the bottom of the ocean. So lava flow, bottom of the ocean floor, submarine volcano. Now that builds up just like at the constructive plate boundary. And over millions of years, it builds up and forms an island. So that is one of the islands of Hawaii. So we've now got back to this diagram now. So here it is. Here's this island of Hawaii. So the whole thing is volcanic. What happens today is the magma escapes through the oceanic crust in weak areas, but most of it's pretty hot anyway, escapes through the island and creates volcanoes. So we've got a little volcano here called Lohi, which is actually underneath the ocean. So that is a submarine volcano as well. Kilauea, I think that's how you say that, and Mauna Loa. So they are two other volcanoes on one of the islands of Hawaii. So the biggest island of Hawaii, surprise, surprise, is called Big Island. Now what you've actually got is a string of islands. So we've got Maui, I think that's how you say it, and then loads of other islands off on this left-hand side. Now, how does that happen? This is stationary, this crust is moving. So this crust moves over the plume and an island will pop up and be created for a few million years. Then the crust will move along and create another island. So to just try and show you this, I've just got a whiteboard. So I'm hoping, if I kind of get this in the picture, the rubber on top of the whiteboard is the big island of Hawaii, and my orange highlighter pen is the stationary magma plume. I know you've got to use your imaginations, but just go with me on this. So this thing here is stationary, but the plate is moving that way. It's in fact moving in a northwest direction. So if you see what happens, as the plate moves away from the magma plume, the island becomes now, well, it's not being fed by that magma from the magma plume. So the magma plume is now under a different part of the oceanic crust, so therefore creates a new island. And so that process goes on. So what you have in this area here is loads of the islands now not being fed by the magma plume. So back to the main diagram. You can see these other islands. So yes, they are volcanic. They're not active now because this magma plume is not feeding them. Other things to note is this oceanic crust is obviously very, very hot here. And as it moves away from this hot plume, it cools and becomes denser. So therefore actually drops. So in your diagram, make sure that you've got the oceanic crust dropping down. And what this does is it actually pulls the islands down underneath the ocean and they start to get drowned. So for example, this one here has been completely drowned and is not habitable anymore. So that's similar to the constructive plate margin. Other couple of things, The plume here gets dragged. So because the oceanic crust is pulling that way, it drags the plume with it as well. The whole features that are produced are called an island chain. So not an island arc, it's a chain of islands. So just to kind of recap, this is the islands of Hawaii. They are formed from a magma plume under the oceanic crust. So going back to the original potential question, magma plumes and their relationship to plate movement, a magma plume is stationary, and their relationship to plate movement is that they create islands above them. The plate moves and you get a string of islands, an island chain.